Hi, everyone. Thanks for attending this Snowflake webinar. It's 10 o'clock right now, but what we're going to do is we're going to give people about a minute or two to all come in and join the webinar. So we're going to start at around 10:02 or so. So thanks for your patience and sit tight. Good morning and good afternoon, everyone. Thank you for joining the Snowflake webinar featuring Rakuten, an e-commerce and online retailing company, and also AtScale, a developer of an adaptive analytics fabric. So this is the basic agenda. We're going to start with Rakuten telling us their cloud journey story, then we'll hand it to AtScale, and then Snowflake will talk a bit about how we've helped Rakuten and other customers. VP of Analytics at Rakuten Rewards, who will talk about his experience migrating to Snowflake and the benefits he's seen from using it. And I'm also joined by Matt Baird, founder and CTO of AtScale, who will discuss how AtScale's technology complements Snowflake and helps many organizations. And I'm Joe Goldberg, a director of product marketing at Snowflake, the leading data warehouse built for the cloud. Please ask any and all questions throughout the duration of the webinar via the electronic Q&A box, and we'll leave plenty of time at the end to answer these questions. I'll also try to answer questions during the webinar as we go. And lastly, this webinar will be recorded and sent to you via email afterwards. So Mark, without further ado, off to you.
Thank you, Joe. Morning, everyone. So as Joe mentioned, my name is Mark Stein-Tregear. I'm the VP of Analytics at Rakuten Rewards. You may know Rakuten Rewards a little bit better as by the brand name Ebates. We recently rebranded after 20 years of history as Ebates. We still do the same thing, though. Rakuten Rewards provides cashback and other shopping incentives to our membership base. We're the largest operating loyalty program in the US. And just to give you a sense of scale, we typically operate, we would say we have about 13 million active members. We work with over 3,500 merchants, and that includes most of the major merchants in the US, as well as some more niche merchants or smaller merchants around the US. To date, our members have been paid $1.5 billion in cashback. It's quite a lot of money. We've been around for a while, but still, the amounts of money that we're able to get back to our members are substantial and really add up. We also do run an in-store program. It's not just online. We can connect credit cards to offers and allow people to earn cashback and incentives in that way. And that program has over 2 million credit cards linked for offers. In the US last year in 2018, and we should easily surpass this by a good margin this year, we posted, or our members placed $9.5 billion in e-commerce sales through our platform. So we're pretty big. we've got quite a lot of history, and we've got quite a lot of data. I've been with Ebates for well over 5 years at this point. Joined the company when it was much, much smaller than it is today. And I have been working on building out the BI function and the centralized BI team ever since, along with a dedicated engineering group. When I joined, I had a very clear set of ideas and principles that I wanted to make sure that we implemented at what was then Ebates. And all of these principles found a pretty receptive audience. I'm somewhat lucky to have a very data-centric executive team, leadership team, and I work for a very data-focused company, which, as people have pointed out over the years, is a blessing and a curse. It means that I don't often have to explain why data is important or why being data-driven is critical. It does mean that the expectations on the data platform, though, have been and continue to be extremely onerous. There is an expectation that the data platform perform very well. And the way I typically think about this is demonstrated by the 4 blocks that you should see on the presentation there today. It's about comprehensiveness, it's about speed, it's about accessibility, and it's about not just providing data for the sake of analysis, but also using data in a real way to do things. So let me just go into each of these things just a little bit in more detail, because I think it really does help to frame the conversation and helps to see where Rakuten Rewards has been with respect to data and where we are today, and ultimately why I'm talking today. So from a comprehensiveness point of view, we do still operate in an enterprise data warehouse. We genuinely try and our goal is to be able to answer any data-based question that comes up within the company. Now, that is not trivial, especially with the proliferation of event-based data and non-structured data streams, third-party service providers that work with data. But that is still a core focus to us. We want users to be able to go to one place to be able to answer questions. We also want it to be fast. So we want to be able to provide real-time, insightful reporting so that we can manage our business on a day-to-day basis and address issues or opportunities as they arise. We also have standard kind of business intelligence-esque SLAs around, making sure that we have reporting data sets available kind of on next-day timeframes so that people can review what happened yesterday, the day before, and make plans moving forward. I also have an audience internally that I don't think is any different to most audiences, and my experience and surveys over the years have found that the people aren't willing to wait for more than 30 seconds, and that's an absolute maximum to get information. If they do, then that's considered boring, problem. They're going to leave, they're going to go do something else. And ultimately, the risk there, of course, is that you move away from using data to make decisions and instead go with gut feeling or, what you think is probably the right idea. And that's really antithetical to where the company tries to be and tries to operate. We also have, over the years, tried to make data available to everyone. This has varied depending on the technology, but the idea is that if you want to use data, if you want to use information to drive your business decisions, whether you're in finance or marketing or sales or product management, then we're going to do our very best to offer you the best tools to be able to make those decisions based on good, accurate data. And wherever humanly possible, we're going to do it in a way that meets your skills and interest in how you want to actually perform that analytical function. The final piece to call out here, as you can see there, is what I typically call data use, and by this I mean not just analysis. If I've got to the point where I'm understanding or a user is understanding some data within our data warehouse, my experience is that the typical next thing is, okay, well, now I want to use that insight, or I want to use that data point to do something else. I want to influence our consumers' experience on the website, or I want to pipe this data into this marketing optimization tool. And we've always considered that just an extension of the warehouse and the warehouse functionality rather than a separate piping or ETL structure. So with that, let me move a little bit onto a timeline. Like I said, I joined in about 5 years ago, so I'm going to run through the timeline since I've been with Ebates and then Rakuten Reward, and walk through what systems were put in place. And what you'll see is a developing narrative here of trying to chase down ever more processing capability, flexibility, and ultimately processing power. As our data's got bigger, as our amount of users have got bigger, as our number of business use cases and scenarios has got bigger, we've needed to bring more power and flexibility to the table. So if we look back at 2014, this is going to look familiar to a lot of people on the call. We were using a SQL Server instance. Effectively, we just had a copy of our production Postgres databases from our core website platform. We had SSRS built on top of that SQL Server. We had a little bit of MicroStrategy out there, and we also had SQL Server Analysis Services cubes that people were interacting with primarily through either SSRS or through Excel at that point to do some drag and drop analytics. And that worked fine until 2015, when that SQL Server machine, we'd bought a pretty big one at that point. It was starting to struggle with the ETL and the workload. We had some users doing some pretty gnarly SQL in there that was causing problems for other users. Basically, we were running out of CPU. And at the same time, we were really growing. We were growing into Canada. We were growing into Korea. We had material distribution of our product line. So rather than trying to just load all of that work onto an already overloaded SQL Server machine, we did what I suspect many of you would have done in that situation or have done. And we copied that stack, that SQL Server stack, and produced different instances for those different business entities. Now, there was some inefficiency in there because of the fact that we've then found that we were replicating a lot of ETL. We had to monitor a lot of different jobs. We had to replicate reports over and over again, even if it was basically identical workflows. There's a lot of replication and inefficiency built into doing that. But at the time, we really didn't see much of an alternative with the tech stacks that were out there and with the size of the team. By 2016, that situation was becoming really problematic. We were finding that we really couldn't keep up with the scale of innovation, and we were starting to look for more powerful platforms that could effectively give us back a single enterprise-level warehouse, but we also couldn't buy a big enough SQL Server machine. And at that point, we started looking at a couple of different options, and ultimately we decided to go with a self-hosted Hadoop cluster. By late 2016, we got ourselves to a situation where we had that Hadoop cluster up and running. We had plugged in at scale, and I'll talk about that a little bit more in a minute. We'd also adopted Tableau as the primary reporting platform. We did still have SQL Server knocking around, but we had decreased our dependency on it and shrunk the SQL Server stacks at that point. In 2017, we actually got rid of that SQL Server stack entirely. Effectively, we doubled down on the at-scale and Tableau technology and then increased the number of Hadoop servers. The thing for anyone who's tried to actually manage Hadoop servers, you will find is that you still hit CPU disk drive issues. there is still a finite amount of resources out there. And ultimately, as your workload increases, as your data volume increases, what we found at least was that we ran out of the processing power. We ran out of the ability to actually we found that we couldn't actually run the jobs that we wanted to run. Certainly couldn't plan to adopt the data sets that we wanted to adopt. And the only real option there now, the advantage of Hadoop is you can build out. So we went ahead and we bought more servers. Added more servers. 2018, that got even more so, and we added even more servers in there. And we continue to grow that cluster out, and grow that cluster out, and grow that cluster out. And that was the approach in 2018. At a certain point, though, the writing was kind of on the wall. Our operations team, our internal team were getting increasingly frustrated with trying to manage these internal, effectively a server farm at that point. It comes with a significant operational overhead, never mind electricity cost. And, the hardware is expensive. It was also still not solving the problem. With the more recent iterations of Hadoop systems, there are various ways to try and protect the system from problematic workloads. But ultimately, you're still using the same disk drives. Right? You're still using the same drives. So if you have if you're trying to process data on a continuous basis, writing to disk, you've got lots of people reading from those disks in multiple different ways, you eventually hit a resource crunch. And ultimately, in mid-2018, we decided this was not the scalable way that we saw the business going, and we decided to shift to Snowflake or into the cloud. And I can talk a little bit about why Snowflake was our vendor of choice there. So in 2019, this is actually really interesting timing. We will literally be shutting off the Hadoop server farm tomorrow. So technically, I'm one day ahead on this timeline, but certainly by the end of 2019, the Hadoop system will have disappeared and we will be on Snowflake. Notice that through all of this, and this is this point that we'll come back in just a minute, we have maintained our at-scale and Tableau implementations throughout all of this, upgrading as we went, but our core reporting platform and visualization platform has remained the same since basically mid-2015, certainly 2016. So that's our timeline. It's a very busy slide once you add everything. Let me talk at this point a little bit about this most recent step. Why did we decide not necessarily to go from Hadoop into Snowflake, but also why did we decide on Snowflake versus the other cloud vendors, cloud warehouse vendors? So, and this links back to where I started with the 4 principles that we adopted very early on, and particular 2. So I've always wanted to provide analytic resources fast and to pretty much everyone that wanted them. One of the key problems with doing that is that sooner or later, and I've hinted towards this already, users start to trip over each other. You can try and protect CPU or memory, and some of the Hadoop platforms did allow for that. SQL Server, to some extent, allows for that. But ultimately, if you're running on a single set of machines, you're going to hit some kind of bottleneck, ultimately, with either CPU or memory or drives, just your hard drive space or the speed that you can get the data off the drive. We've hit all 3 of those at different points and tried to juggle that, but ultimately you're just moving the problem around. If you're dealing with limited resources and you've got a growing use case, ultimately you're going to use those resources, and then what's going to happen is things are going to slow down, things are going to start failing, and you're going to start having problems being able to retrieve the data in the way that you want and in the speed that you want. The thing that Snowflake brings to bear here, and one of the absolutely core value propositions that we see in Snowflake, is the fact that you can use discrete warehouses, separate warehouses, effectively separate processing clusters to interact with the same data. So you have centralized data, you have discrete clusters of processing. What we did is we effectively set up different warehouses for each different business unit, even in some cases for different parts of our ETL processes, so we can protect them from each other. At this point, if someone on my marketing team goes in and writes some problematic SQL, they may slow things down for the rest of the marketing team, or they may cost us some money, but they have no impact on my finance team or on my ETL or on my sales team, right? Or any other team that's working on top of the data. Same thing, if the sales team, has a big conference coming up and is hitting the system really hard, that has no impact on marketing's ability to get the data. And that is just a huge benefit. It also means that I can predict SLAs and data delivery timeframes much more accurately, because I haven't got processes or jobs slowing down just because there's ad hoc workload coming into the system that I couldn't predict. It also means that I can optimize my costs better, because effectively within Snowflake, I can modify the size of the cluster to what is actually being used rather than a one-size-fits-all. So if I have a job that really doesn't needs to run consistently, but doesn't really do a lot of heavy processing, I can put that on a much cheaper cluster and save the money, whilst at the same time having a much heavier processing, maybe a data science job that needs a lot of CPU power. I can put that on a big cluster and still run it within SLAs, and I don't have to try and find a one-size-fits-all solution. One of the other key differentiators that we saw with Snowflake was the data use point. Right? Typically, like I said, when we produce some kind of data product or analysis, the next question is, okay, well, can we send this to here? Can we send it to there? Can we use it to do this? Can we use it to do that? One of the difficulties with doing that is that often involves lengthy, complicated ETL development processes, often with third-party vendors, where the ability to double-check that integration or to go in and look at the data sinks is, somewhat difficult, if not impossible. And one of the things that we loved about Snowflake was the movementless data sharing. I can create a data set, I can share that, and we use this routinely with external vendors and with some internal groups. I can share that data without having to build any kind of ETL pipeline or doing any kind of data movement. There's no data sync, because effectively what I'm doing is I'm just giving those vendors or those other internal groups limited access to my data. I'm not actually producing a copy of the data. I'm just giving them a pointer back to my data. So when their view of the data is always in sync with my view of the data, because there's no actual sync, if I need to remove access to that data point, I just turn it off. It's a line of SQL. If I need to add a data point or to modify historical data, not a problem. I just do it, and they'll immediately see those changes replicated. And that was a huge benefit to us, and a huge differentiator for us as we were looking to adopt a cloud platform. So that's a little bit about Snowflake. Let's talk a little bit about at scale. So again, thinking back to those key principles, one of the things we wanted was speed. Now, Snowflake does a very good job of optimizing queries, and I could spend a whole hour talking about how much that's helped. But at scale adds another layer of optimization on top of Snowflake. Ultimately, if you're joining billion-row tables together, that takes a little while. At scale as an optimization system can identify repeated querying patterns and effectively eliminate the need to go back to the raw data, or can significantly reduce the amount of time you have to go back to the raw data. What that means is that, again, I can use much smaller clusters, and I'm going to get results. because what I'm actually doing when I issue a query that AtScale handles is it's going typically back to a small pre-aggregated table. There's no joins to do, there's no aggregations to do, which means I don't need to bring a whole lot of processing power, and it comes back fast, right? You can retrieve data from a 10,000 row pre-aggregated, pre-joined table much faster than you possibly can joining two 10 billion row tables together. So that really helps with the speed. It helps with my users. Typical query, if I've got a user doing drag and drop, typically, 4 to 5 second wait time is all they have to wait through to get the results back. And often it isn't even that. And also, what that allowed me to do was to combine, to put Tableau on top of this stack very neatly. You could use other tools as well. We just happen to use Tableau. And that allows me to provide drag and drop analytics, natural language processing analytics directly on top of these optimized pre-aggregated tables, which means that, I don't have to have a user base that are all geniuses in SQL. Definitely have some of those, but it isn't a buy-in to be able to use data, right? You don't have to have a data science qualification to be able to use that data. You can go in and you can drag and drop and find material business benefit by doing so. So we really bring those barriers down and going back to the earlier points, make the data available to all. So with that, that's kind of the framework. At this point, I'm going to hand it over to Matt, and he's going to run you through kind of the at-scale value proposition and tech stack in a little bit more detail.
Thank you, Mark. So I'm Matthew Baird. I'm one of the co-founders and the CTO. And when we talk about at-scale, we are a multi-dimensional analytics, business analytics company. We serve people that are doing business intelligence and advanced analytics, such as machine learning use cases. We started in the Hadoop space, and we learned we have a love-hate affair with Hadoop. It can be very challenging. It can also be the right tool for the job. But after we got started in Hadoop, we quickly moved to cloud databases, which I really do, and we really do see as the future of the data architectures. And we moved in the traditional space. So what we allow is for people that want to scale to a very large amount of data or lots of data spread across many different data warehouses to get a universal semantic layer on top of their data, which means they can define how the data relates to the real world artifacts, such as hierarchies and dimensions such as time or geography, without disrupting the business users' use of their favorite tools, such as Excel or Power BI or Tableau. So we are a bi-coastally company, and we focus on performance as a differentiator, security, analytical agility, and as Mark said, there is a cost predictability. So typically we don't find that people spend less money, but they do develop more analytical use cases and roll them out to more folks. We started in 2013, and Mark has been one of my favorite customers since around 2014, as per his slide. We partner up. We do not replace any data warehouses. We do not move the databases. We do not move the data out of the databases into us. We use the infrastructure that you've chosen, in this case, Snowflake. We use it to the best of our ability. And the technology that we bring to bear, we refer to as autonomous data engineering. So once you've landed data in any data warehouse, there's often a step to make that data suitable for a production analytical use case. And that often involves some very expensive and scarce resources, either data ops team, or you might call them data engineering. And those folks are valuable for a lot of other different, more highly strategic projects than doing some of the stuff that we do in an automated fashion in response to natural user requests. So We model once, and in this case, we started with the journey with I want to call them Ebates, but they're called Rakuten now. We started the journey with them on Impala and Cloudera Hadoop, and we used the exact same project, and they were able to lift and shift over to Snowflake, and in a non-disruptively way, enable the use of that amazing cloud database without interrupting the use case from the business perspective. So we automate the data pipeline from sourcing. You source the data into your system, but you have to curate it, you have to stage it, you have to prepare it, you have to build a semantic layer, you have to apply security, and make sure that security is applied to all downstream tables. And then you have to create integrations to support all the different tools and technologies such as Excel or your Jupyter notebooks or whatnot. You have to then run a project to performance tune and do user acceptance testing. And we automate that. Sorry, I'm having trouble getting this to build. Can I ask somebody how this builds? Oh, there it is. We replace the first part with a drag and drop modeling environment. We support the second part by automatically sourcing and building the data models into these acceleration structures, as Mark talked about, which are used transparently. You do not need to tell your users about them. They're just used on behalf of you to accelerate queries. And then we deliver this in a way that's testable. And since it's done by a machine, it's proven to work. And UAT is a breeze at that point. So really what we're doing is we're trying to enable self-service analytics and reporting for folks that have a large amount of complex data. I want to leave a lot of time for our Snowflake friends to talk about their solution.
Great. Thank you. So we're going to go ahead now and proceed into the Snowflake portion of the webinar. And again, if you have any questions, definitely submit it via the Q&A. We've already got a lot of good questions that came in. And when I'm done here, I'm going to kind of verbally go over the Q&A with the other speakers. So Snowflake, this is our mission. Our goal is to enable every organization to be data-driven, which basically means harness all of their data in order to run advanced analytics on it, to answer all the business questions that they're facing, to improve their bottom line. The current problem, basically why organizations turn to Snowflake, is going to be listed here on the slide. Sorry. And frankly, Mark touched on a lot of these when he was going through the Rakuten story. Basically, the problem here is the opposite of Snowflake. Again, it's why people turn to us like Rakuten. So number one is they have siloed diverse data. So they find that their data is scattered across different sources and data stores like Hadoop, which Mark had mentioned. Also, they find that they have to keep their semi-structured data in a different repository because they can't put it into their data warehouse. And there's no data sharing capabilities as well. So it's very hard to share data with externals. End result is you've got no single source of truth. So your analytics are not as good as they could be. Point two, most organizations, especially the folks using an on-prem data warehouse, they're struggling with scale and speed. And they're having scale up and out issues that Mark touched on earlier. They just have limited compute in the existing data warehouse, and it has to be shared across all workloads, all ETL jobs, all end user BI queries, and you have slow queries, you have slow data ingest. It's just not performant at all. You can't do fast analytics. Point three, it's a complex, costly infrastructure they're dealing with. Especially in the on-prem world, when you've got to go out and provision high-end hardware and deal with that, it gets more expensive. But they also have to over-provision it, right? We have customers in retail that have to over-provision for things like Black Thursday, and literally 80% of their infrastructure is unused outside of the Christmas season. That's just a waste of money, essentially. Lots of maintenance and tuning, pruning the data stores, doing vacuuming, all that fun stuff, and a lot of languages to deal with, especially if you're using open source. Maybe it's using MapReduce, Python, et cetera. So it's expensive and costly. And what this equals, or what this leads to, is the fourth column there. Basically, slow, limited decision making. A lot of lot of organizations, before using Snowflake, had to limit how many people could use the system, how many queries they could run. They were dealing with stale and incomplete data, and they just really couldn't do the analytics they needed to. And again, Snowflake's the opposite, and I'm going to show you how we're the opposite in an architecture diagram that's coming up here. So this is again, we're still with the before, kind of the problem scenario here. This is what a legacy architecture looks like for a lot of organizations. On the left, you've got your data sources, you've got ETL kind of moving into an enterprise data warehouse in the middle. At the bottom, notice there's unstructured data, which won't go into the EDW. So maybe there's a data lake like Hadoop being used, but you've got silos, right? Problem number one. And if you notice, you have data marts over there on the right side. And that's because the EDW is suffering from scale and performance and speed issues that I mentioned earlier. So you got to give people data marts or slices of the data. So that's adding cost, that's adding complexity. It may not be synced up with the master data in the EDW. And you're going back to the problems of silos, et cetera. Down below, notice for sharing, a lot of organizations have to share data with externals by literally sending CSVs around. Maybe they're password protected or not, but it's highly insecure and it's not manageable. And then on the far right, you've got your BI analytical end users, but basically a lot of pain here. So next slide is Snowflake. Okay, so it's the same architecture, but a couple things have changed here. First of all, the data lake at the bottom is gone, because Snowflake can take in your unstructured data. It can be a data lake and a data warehouse. It can take in all the data in batch, in streaming, put it in one location. So no more data silos. It's all in one place. And no data marts off to the right, because you don't need data marts, because Snowflake has essentially infinite scale. Everyone can access the original data. Everyone can use it for analytics. No more data silos, which of course is a big value proposition for our customers. And it's also worth pointing out here that Snowflake is offered fully as a service online, so it's a very simple infrastructure, very cost-effective and low maintenance. No pruning, no vacuuming, no partitioning, no manually optimizing queries, et cetera. And one other thing I do want to point out is the third line with externals off to the right. Notice the CSV is gone because Snowflake enables data sharing. And someone asked us in the Q&A, they said, how do you share data if someone's not if who you want to share it with isn't a Snowflake customer? And what you could do is you create what's called a reader account. So any external party can create a reader account and access your Snowflake environment as though they're just an end user. So it's a very easy way to provision externals to access the data that you're possessing inside of your Snowflake account. But the bottom line here is the infrastructure is simplified. There's no silos. It scales infinitely, low maintenance. Data is democratized. Every user can access the system to run any query they want to. So a lot of pain gone. This next slide, I'm going to get a little bit more technical here. I want to drill into our architecture because that's what really makes us special and unique versus not just on-prem solutions, but also other cloud data warehouses. So it's worth pointing out that in the middle, of course, that's where all your data is stored in Snowflake, and all workloads, all end users can access that same data inside the EDW. Everyone's got access to it. But what's nice is all the workloads can get their own compute, or what we call virtual warehouses. And those are represented by the cogs on this slide within the blue box. So those are dedicated compute resources for each workload, whether it's ETL or BI. And to think of those as being, for Amazon, it would be Amazon AWS EC2 nodes under the covers. And you can sort of size the warehouse appropriately. So let's say data science, lower right, they're only running a couple of queries. You can give them a small cog, or basically give them a small amount of compute. Maybe it's a small size warehouse. You're giving them, I don't know, making up stuff here, 10 EC2 nodes to run their jobs, okay? But what happens is, let's say they start to run bigger, more complex queries. What you can do with just a few clicks in our UI is you can increase the size of that single virtual warehouse to make it maybe from a small to a medium or an extra large. And under the covers, we're automatically giving them more EC2 nodes. And we can give them up to 128 EC2 nodes for a single virtual warehouse. So literally 128 machines, compute machines, we're allocating to that one single workload in a matter of seconds. And what's nice is that's just data science's warehouse. So there's total resource isolation. What they're doing does not affect any other BI user or department, doesn't affect any other ETL job. So what we just did there is we scaled it up, the data science cog, Now let's switch over to the left, where let's say we have a warehouse assigned just to ETL jobs to pull in data. And one nice thing about Snowflake is you can auto-suspend all these warehouses. So when they're not being used, they suspend. You don't get charged for it. In this case, let's say there's no ETL jobs running. Notice the cog went away. We just suspended the warehouse. You don't pay for it. It's off. As soon as someone initiates an ETL job, though, it'll come right back. So we can, it's sort of automatic suspension and turning back on of all these compute resources. And the last thing I want to call out is let's look at the top right, the cog next to marketing. So they have their own virtual warehouse with its own dedicated compute resources. And let's say it's working great, but suddenly marketing says, hey, we want to add more users. And they add 100 more users to access Snowflake. Well, now we've got concurrency issues. And the way you address concurrency is you want to scale out a single warehouse to make it multi-cluster. And in Snowflake, a couple clicks, you can make that single warehouse, you can make it multi-cluster up to 10 clusters. In this case, we're just showing 2 visually. But that's literally could be 10 clusters, 128 nodes. We're talking almost 1,300 physical machines in a single warehouse in seconds. Good luck doing that with physical hardware, right, in an on-premise world. So that is the scale, the unique architecture of Snowflake that really enables incredible elastic performance, scale, and speed. In terms of use cases, there's obviously the core data warehouse use case, top left. I mentioned how we can also be a data lake, store all your structured, unstructured data. Accelerated analytics means all your business intelligence tools and users can use the system. On the far right, there's data engineering, where we can help with data pipelines, ingesting data into Snowflake, and we can do some basic transformation along the way when data comes into Snowflake and from table to table, and we can even transform enriched data and then export it back out to a data lake. There's data sharing lower left, which I mentioned, very easy to share data with both other Snowflake customers and non-customers, whether it's inside your org or outside your org. The data applications point just means that we have a lot of organizations that build applications on top of Snowflake. We're essentially the back-end hidden data warehouse that they use for back-end analytics, so they can focus on the front end and logic, not the back end. And then for data science, we'll work with R, Python, any popular data science tools, so you can run analytics and data science on the data in Snowflake. We're up to over 2,500 successful customers all across the globe, large and small, every single industry. A couple of use cases listed here, and the common theme across the use cases is around, more users, faster analytics, scale, speed, et cetera. And it's those customers include Rakuten, where here's a quote from Mark: "Adopting Snowflake was the easiest part of our cloud transformation, thanks to AtScale. Reporting at-scale adaptive analytics from our Hadoop environment was seamless for end users." So that's a great combination there of both Rakuten and at-scale and Snowflake coming together to enable these benefits for Rakuten that Mark covered earlier. Again, we're comprehensive, fast, available to all, and data use goes up substantially with Snowflake. So with that, we're going to pivot over to the Q&A portion of the session, and I'll pause for a second to give people some time to go to the Q&A box, submit a question. And while you're doing that, actually some questions did come in, which I'm going to pass over to Mark. So Mark, you probably want to unmute yourself. Now I'm going to go in the Q&A, and I'll start with, let's see here. One of them was just, can you elaborate on what real-time means for Rakuten?
Yeah, so the business use case that most typically comes up is, because we work with 3,500 merchants, we see shopping and behavior trends from our members, fluctuate through the day. If one of our merchants has a blowout sale, we'll see that. If one of them is experiencing website issues or other functional issues, we'll see that. And there's a premium on us understanding exactly where we are during the day. In particular, if we are trying to tune the performance for certain merchants or certain parts of our platform, it's important that we get, pretty close to real-time feedback. So at this point, we're not quite on real-time. At this point, we do have some stream functionality, but the core data that we look at in very close to real-time is effectively processed in micro batches, like every 1 to 2 minutes. So typically, for the more responsive, close to real-time reporting, you'll be looking at a Tableau visualization, maybe somewhere between 3 to 4 minutes behind when actions were taken within our application platforms or within our database, production databases.
Gotcha. Another question is just simply, this is probably a quick answer here, but it's what type of Snowflake deployment do you run? Is it a virtual private Snowflake or one of the other editions?
Yeah, it is. Virtual private.
Okay.
Yep.
So, okay, virtual private Snowflake.
Yeah.
Gotcha. Okay, and if you're comfortable answering this, what type of data sets are you dealing with in terms of like just size of the terabytes, petabytes? How large is the deployment?
Yeah, so the data sets would range over the kind of data that you would imagine a company like us having. We obviously have member user information. We have data about their shopping and ordering history, as well as streams around the website and mobile app events that happen. We also have things like CRM data sets to manage our B2B side of the business. Data sets coming in from systems like Salesforce and Zendesk that allow sort of functional operations within the company. We house all of those in Snowflake. We're in the sort of couple of petabyte scale at this point. A very large amount of that driven by the sort of behavioral clickstream data coming in from the application layers. And to me, one point that is worth noting here is that what we actually did within Snowflake, we didn't think of it as the data lake or the data warehouse solution. We actually thought of it as a combined solution. So our entire data lake is within Snowflake. We then build our data marts, data warehouse, aggregate tables also within Snowflake. And we did that in a way that we can now, what that means is I can hook up all the same data delivery, data visualization, data modeling, data science tools to any combination of the data warehouse or data lake tables. Obviously, if you're using the data lake, you can take some efficiency hits and therefore some cost hits, but there's no, it isn't siloed. And we do joins between data warehouse tables into data lake tables for more nuanced use cases all the time. So one of the nice things about the scalable architecture is you really don't have to worry about doing things like that, and you can break down some of those more traditional barriers where maybe the data lake was held at a higher level of granularity, maybe on some slower hardware, and then you sort of aggregate or bring data warehouse tables that are already sort of pre-processed into a separate location or a separate system, and which is fine until you have to change something, right? Or you want to use those data sets in combination, and that can become a real headache.
Gotcha. Another question, this can be a kind of quick one too, is what ETL or ELT tools are you using to ingest data into Snowflake?
We actually home grew our solution. We did take a look at a lot of the solutions out there, and we do use some bits and pieces of what I would think of as connection technologies to work with third-party applications like Salesforce and Zendesk would be a good example. For our internal databases, for our event feeds, we home grew the solutions for various reasons. Some of which are a little bit nuanced to us, some of which was the fact that we already had a lot of that logic already embedded into code that we could move into the cloud relatively quickly and easily. So it was actually a less expensive option than trying to stand up a new ETL tool at the same time as we were trying to shift the data storage and all the reporting and all the data use into the cloud. There are some good tools out there. Would we make that decision again today? Probably, but I wouldn't say that is a universally true thing. There are some great tools out there that, if you didn't have some of the nuances that that we have, or some of the business situations, you could realistically go with one of the existing tools and be perfectly happy.
Gotcha. And then another question came in, you kind of, I guess, somewhat related to ETL, but how complex was the redevelopment efforts when you migrated all your old Hadoop ETL jobs over into Snowflake? Like, how many months did that take, project?
Yeah, it was complicated, but not particularly the Snowflake piece. In fact, Snowflake made it a little bit easier. So our Hadoop jobs were primarily written in Python and Scala, mainly using Spark, but with some Impala SQL thrown in as well. I think I would say one of the primary challenges was rewriting the jobs so that the ETL jobs, like I said, we built our own system. So one of the primary difficulties there was getting that code base, even though it could be lifted and shifted, into the cloud, right? So into a Docker, Kubernetes, AWS framework, because we actually do a lot of the ETL processing before the data's landed in Snowflake. What we found is once we got that framework in place, the actual code migration wasn't all that complicated, but getting the systems to work in the way we wanted to within AWS did take a while and did take some engineering effort. Where Snowflake actually helped is that because of the complexity of that, once we'd actually migrated a good chunk of the workload and we had a much better sense of being able to quantify and measure the costs, we actually did decide to take chunks of the ETL, and rather than processing them via Python, Scala, Spark frameworks, we actually just rewrote them into Snowflake SQL and then just ran them on Snowflake instead of replicating that all of the workload as is or in code. I think so. We ended up with kind of a hybrid solution. I think that put us in a pretty comfortable place, and it puts us in a pretty good place to optimize moving forward. In terms of how long did it take, we kind of did this over the whole project. We sort of ran over about 7 months, but I think the core code development sort of went in. Anyone who's done one of these, I think this is a fairly common experience. It goes in kind of fits and starts. And we sort of did rolling. We didn't shift the entire data warehouse and then do a second phase to shift all of the data use. We sort of shifted reporting, data extracts, transfers, and so on as we were going along. So we probably could have moved the technology in the warehouse faster. But since we were on timelines where we were moving sort of the downstream use of the data as well in parallel, it did take us about the best part of 7 months to really get through the guts of the migration.
Gotcha. So I've got a question now for Matt. Actually, two questions I'll kind of put in there. One is, does AtScale support the same extent of automation to Azure like S3 that was shown in the slides? And then also, there was a little bit of confusion in the Q&A in terms of, AtScale versus ETL versus BI tools. So you can try to plain English the difference for folks.
Absolutely. So for all the platforms that AtScale supports, which includes Snowflake and BigQuery and Redshift and on-premise and Hadoop, we support the same technology and the same functionality. So from that perspective, in Azure, yes, we support it. We support with an S3 backing. And in fact, on Snowflake, a very nice thing to do is to have a huge amount of data in S3, which is a cost-effective way, but not the fastest way to query the data, and then have AtScale's technology create the acceleration structures of the tables inside of Snowflake, not in S3, using their technology to make sure that those queries are fast. So that is a way to maximize the spend on and minimize the spend on storage, which can add up if you've got a tremendous amount of data, as well as getting the benefits of performance acceleration. On the second question, can you remind me? I apologize. Joe?
Oh, yeah, sorry. So yeah, one was on the differences between ETL, BI, and the other one was Azure automation. So we are not in the ETL business, although we at times do things that approximate that. We think of ourselves more as a company that's looking at
the data engineering tasks that would happen when you try to productionize and accelerate use cases. So that involves the creation of those aggregations, as we call them, acceleration structures, and where to store those and how to serve them up and how to rewrite queries to be more performant on the underlying technology. So for instance, some BI tools generate SQL that really tortures the database, and we can help rewrite those to focus them and optimize them for the underlying technology such as Snowflake.
Gotcha.
But we're not in the lift and shift. We enable the ability to do a lift and shift and then point the same at-scale project and not disrupt the end users because they just talk to at-scale and at-scale talks to the data warehouse. But we're not in the business of wholesale moving your data from, say, a Teradata into a Snowflake. That's a tool for another company.
Gotcha. Perfect.
I think, and let me just add on to that. I think that notion of movementless data applications is a big one, and I think it's where I see a real synergy between at-scale and Snowflake. You know, with Snowflake, it's movementless data sharing. With at-scale, it's movementless data use optimization is the way I think about it, typically speaking. This isn't a foreign concept to a lot of the visualization tools in the space. I think where I am seeing increasing interest is movementless data applications. There are now applications that work directly with Snowflake to send email, for example, without having to actually move your data anywhere. So movementless data science applications. This is great, and I think Snowflake, one of the core things that Snowflake, I didn't talk about this too much, has allowed us to do is implement those types of applications and allow Snowflake to manage sort of the cost and see all of my processing costs effectively in one place. And again, I don't have to replicate data silos, which always makes me happy.
Yep, gotcha. So we've only got a couple minutes left of Q&A here. So what I'm going to do is there's a couple in there that rolled in for Snowflake. I'm going to address real quick, and I'll kind of do them in quick answers here. So question was, what cloud platforms does Snowflake run on? What BI tools will it work for? The platforms we run on are the big three: Amazon AWS, Microsoft Azure, and we've announced support for Google Cloud Platform. And we'll work with essentially any BI tool. I mean, as long as they leverage JDBC or ODBC, we'll work with it. And we have drivers that offer APIs for Python, R, Spark, some other languages as well. And on that note, we will work with any data science technologies like Spark or R that leverage things like JDBC or that we have a connector for. Question came in around scale for Snowflake and the max scale, and the answer is it really is unlimited because we're leaning on the underlying hardware of the cloud provider, which is unlimited. You know, our largest customers are over 15 petabytes stored. You know, over 3 million warehouse jobs a day, so pretty substantial. Someone asked how best way to get data into Snowflake. There's a lot of ways to get it in. Some people batch it in from S3 or cloud storage via the copy command, or a lot are starting to now stream it in using our Snowpipe product, which can automatically ingest data from cloud storage into Snowflake. And that can also leverage Kafka or streaming technologies to stream it in. And then, of course, third-party ETL tools is another very popular option for folks. Someone asked about what types of semi-structured data can we index. We can take in JSON, Avro, Parquet, XML, ORC, CSVs, XLSs. Someone asked, can we take in images? The answer is no. We don't take in things like images or MP4s or Word docs. It's got to be this semi-structured data for us to ingest it. Someone also asked about how secure we are. I could spend an hour on that one, but it's very strong. Your data is always encrypted in transit and at rest. We offer IP-based whitelisting. We do have very granular roles-based access control within the system to limit what people can do and see. We offer optional multi-factor authentication, and we'll integrate with any sort of SSO product, and we can leverage OAuth as well. So we're very secure. We've got SOC 1 Type 2 certification, SOC 2 Type 2, HIPAA and PCI, et cetera. So with that, we are basically out of time in terms of the Q&A. We're going to follow up with you on any unanswered questions. A few closing comments too is in the resources box. You should see on the screen there's more information for you if you want to learn more, including some content around Rakuten and at-scale success. And I also encourage you to go to snowflake.com, or at the top right of the page, you can sign up for a free 30-day trial, which includes a self-paced tutorial and demo data to load into Snowflake. And on the website, there's a resources tab with a lot more content, and you can see all the virtual and in-person events we're having. And there's information on there to contact sales if you want a deeper conversation. And again, we're going to send you an email after this with the recording of the webinar as well. So lastly, a big thank you goes out to our speakers, Mark and Matt. Thank you guys. You did a fantastic job. And with that, have a great day, everybody. Thanks for your time.
Thank you.